Almost every action we take on a digital system can leave a trace. When someone signs in, enters a wrong password, opens a file, or requests a page from a website, the system can automatically create a written record of that activity. These records are called logs. Logs are created by websites, servers, applications, and devices. They are not video recordings, and they do not explain what happened. Instead, they record individual details such as the time, the account, the source address, the action, and the outcome. One log entry may appear insignificant, but when thousands of entries are examined together, they can reveal whether activity is routine, suspicious, or incomplete. These digital activity records are the evidence that SentinelFlow receives and analyzes. We built SentinelFlow, a human-supervised cybersecurity log analysis prototype. A user can paste or upload supported log data, and the system preserves the original records, analyses them through connected AI agents, validates the proposed findings against a controlled security rule base, and presents the evidence for human review. The final output is a clear and traceable security report. SentinelFlow does not disable accounts, block addresses, or perform autonomous remediation. To implement this design, we used Flowise agent flow to connect 5 specialized AI agents with deterministic controls and human approval. Flowise is our internal development and diagnostic environment. The user does not interact with Flowise directly. The supported user journey takes place through the SentinelFlow website. The workflow begins with the input normalizer. This deterministic function converts supported log formats into one consistent evidence ledger while preserving the supplied records. Agent 1 is the orchestrator. It examines the normalized case and selects the appropriate route, but it does not make the final security decision. Agent 2 is the simple analyst, which handles narrow and lower complexity evidence patterns. Agent 3 is the complex analyst, which examines multi-event cases, correlations, and the relevant rules retrieved from our controlled security rule base. Neither analyst can send its result directly to the final report. The structured analysis must first pass through a deterministic validator, which checks that every event is accounted for, the evidence is preserved, the rule references are supported, and the severity matches the rule contract. Agent 4 is the independent supervisor. It either approves the analysis or returns specific revision feedback. If a revision is required, the feedback is routed back to the selected analyst. If the revision limit is reached without approval, the automated process stops and the case is referred for human review. Agent 5 prepares the human-readable report draft from the analysis that has already passed validation and supervisor review. It cannot change the canonical evidence, and it cannot release the report. The report is then presented at the human review checkpoint. Even after human approval, a deterministic release gate checks the evidence integrity before publication. This separation of responsibilities is our main safety control. No single agent can analyze, approve, and release its own work. Now we will demonstrate this complete control path using real log evidence. We selected 3 cases for contrast, and we recorded the expected outcomes before reviewing the observed results. The first case contains supported benign key-value activity and should remain no_alert. The second contains repeated authentication failures without a later successful login and should be referred for human_review. The third contains 5 failed logins followed by a successful login and should produce an alert with high severity. The test is not simply whether SentinelFlow produces an answer. The answer must match the evidence, the cited rule, and the exact severity contract. We will now show how these 3 evidence patterns produce 3 different decisions. The first demonstration is a simple 2-event key-value case. The activity includes a failed login caused by a mistyped password, followed by a successful login from the same source. After submission, SentinelFlow preserves both canonical event records and returns no_alert under rule SF-benign-101. The review-ready draft includes the real case identifier, the covered event identifiers, and the rule reference, so the decision can be traced back to the evidence. This case matters because a safe triage system must not only detect suspicious patterns, it must also avoid unnecessary escalation when the benign conditions are actually supported. No autonomous remediation is performed. The second demonstration uses an allow-listed OpenSSH excerpt from the published LogHub teaching dataset. Its expected outcome was recorded before testing as human_review. After selection, SentinelFlow validates the source and prepares 5 log lines privately in memory. The supplied evidence shows 5 failed password attempts for the root account from one source address, but no later successful login. SentinelFlow routes the case to complex analysis and returns human_review with medium severity under rule SF-AUTH-202. This is controlled abstention, not a failed decision. The supplied excerpt does not establish whether the source is trusted, whether the activity is expected, or whether related authentication events exist. All 5 event identifiers are accounted for. Ledger validation passes, and the supervisor approves the draft. However, the report still waits at the human approval checkpoint. We check the canonical evidence, record reviewer feedback, and approve the report for PDF release. The deterministic release gate rechecks the evidence before publication. Approval releases this report only. It does not authorize operational remediation. The final report retains the case identifier, event evidence, rule reference, and proposed follow-up actions. No autonomous remediation is performed. The third demonstration uses a controlled 6-event, pipe-delimited authentication case. Its expected outcome was recorded before testing as alert with high severity. After selection, SentinelFlow validates the source and prepares the 6 supplied log lines privately in memory. The evidence contains 5 failed login attempts for the administrator account from the same external source address within 14 seconds. 4 seconds later, the same account successfully logs in from that same source. This complete correlated sequence satisfies rule SF-AUTH-201. SentinelFlow routes the case to complex analysis and returns alert with high severity. The alert does not claim that an account compromise has been proven. It means that the supplied evidence satisfies the controlled rule threshold and requires further investigation. All 6 event identifiers are accounted for. Ledger validation passes, and the supervisor approves the draft. However, the report still remains at the human approval checkpoint. We check the canonical evidence and record reviewer feedback, confirming that the evidence and cited rule were reviewed. We then approve the report for PDF release only. The deterministic release gate rechecks the evidence before publication. The released report retains the case identifier, all 6 event records, the rule reference, the proposed analyst response, and the recorded human decision. Approval releases this report only. It does not authorize operational remediation. No autonomous remediation is performed. The verification manifest does not claim broad format coverage. It documents source attribution, preparation, and 1 contemporaneous set of SentinelFlow executions for 3 published LogHub excerpts. The expectations were committed before execution, although they were not formally pre-registered. For each case, the expected root and decision are presented beside the observed root and specialist decision. The first 2 cases matched their predictions and reached approved report release. The third case matched the human_review routing boundary, halted before specialist analysis, and produced no report. Each execution records the source lines, event count, case identifier, Flowise session, input fingerprint, pass warnings, and release outcome. The LogHub repository, license notice, and academic paper citation remain attached. Our verification claim is therefore limited to these 3 documented executions. 3 observed failures directly changed the final architecture. First, JSON content containing embedded characters was damaged while passing between workflow nodes. We introduced UTF-8 base 64 transport and added an end-to-end regression test. Second, severity changed between otherwise equivalent runs. We strengthened the deterministic validator so that rule-specific severity must exactly match the permitted value. Third, the model-mediated report composition step duplicated or reassigned event evidence. We removed evidence assignment from the language model and introduced a deterministic report builder followed by an evidence integrity release gate. We report these failures because they change the architecture. The fixes do not prove that every possible failure has been eliminated. Our evaluation therefore shows how observed weaknesses were converted into explicit, testable controls. SentinelFlow is our working prototype. Log Detector is our future product direction, with its brand identity ready and a dedicated domain planned. Our goal is simple: clearer evidence, safer decisions, and human authority retained at every stage. Thank you for watching.